yeah, I'm going to color code again. F of x in blue, g of x in green. Just draw a quick little sketch of both of them. F of x is square root graph. And g of x, y-intercept, positive slope, looks like that. Domain, x is bigger than or equal to 0. Range, y is bigger than or equal to 0. And for the green one, domain is everything. And the range is everything. Oh, and by the way, the last question, I've never seen on the provincial exam a piecewise graph. Okay, so not to say that they don't start this time, but it's helpful for next year in AP Calculus, definitely helpful, but I've never seen them put a piecewise one when they multiply or add or subtract equations. So part B, we want Q of x to be f of x over g of x. So we're dividing our functions. That would be the explicit equation for Q of x. And we want to find its domain and its range. Domain, you can figure out the domain from its equation, but the range, you're going to need the graph. So let's see if we can draw the graph first. First of all, how do we divide? Right? You could do a table of values here as well. Table of values is very powerful. But some things to remember. Do we remember that if one of the graphs doesn't exist, then your new graph is not going to exist? So for example, there's no blue graph when x is negative. There's going to be no Q of x when x is negative. Which kind of makes sense because you have the square root built into your graph. Can I plug in a negative number? Absolutely not. I could plug in 0, and if I plug in 0, 0 divided by negative 2 will give me 0. So I'd have 0 comma 0. Other things that were important. I'm having trouble with colors today. Other things that are important is whenever you're dividing, you cannot divide by 0. So does it make sense that at 2, right, and that's on our green graph right there, where our green graph is 0, at 2, we have a non-permissible value. Non-permissible values are either asymptotes or holes, and any time in the graph that the non-permissible value doesn't simplify and go away, it's going to be an asymptote. We're going to have an asymptote there. Based on what I see here, does it make sense that I might want to plug in 1? I could either go for my graphs or just plug it in, which I think is easier. If I plug in 1, I'm going to get negative 1. Also, does it make sense that the x-intercept that I found is the only x-intercept that there's going to be? The only place that my fraction would be 0 is where my blue graph or the top of my fraction would be 0. And that only happens once. So once I find that point, it has to go towards my asymptote. I need to plug in some points bigger than this. Typically, I'd probably choose 3 next. But then I looked at my equation and I was like, oh, wait a minute. I think I'll choose 4. Anybody see why I might like to pick 4 instead of 3?
It's easier with the top part?
Yeah, easier with the top part. Square root of 4 is 2. 4 minus 2 is 2 on the bottom. 2 divided by 2, you're going to get 1. So we got 4 comma 1 in there as well. So I've got a point. We also are going to, with the dividing ones, use some of the stuff we learned in chapter 2. This has a square root as an exponent of a half. It would have a degree of a half. this has a degree of 1. What happens when the degree is bigger in your denominator? You had an asymptote at y equals 0, which is actually enough information for us to sort of say, I think this is going to look something like this. Now our domain is x is bigger than or equal to 0, but then we also have to say, with the exception that x cannot equal 2. You can either write it that way, or you could go from 0 to 2, round bracket, and then start again and go from 2 to infinity. Both of those notations would be fine. The range is a little messed up. The range is a little messed up because it's everything, even though it's not connected. It's kind of weird. Because on the left side, do you see that the y values would be less than or equal to 0? And on the right side, because of the asymptote, the y values would be greater than 0, but not equal. But if you included every y value greater than 0, and every value less than 0, and you're including 0, you have every value of y, even though it's not connected. It's kind of a little weird. So, again, I would probably suggest getting the explicit equation, using that with a table of values and some of your other skills to draw your graph, and then you'll be able to say domain and range. Because you can get the domain directly from the equation and don't need to graph, the exam likes to ask a lot more domain questions in these rather than range. Because the range ones can get tricky. In fact, I think some of the ones in your homework, your best way to figure out the range is actually to use graphing calculator or Desmos. Okay, questions you can circle. 6, 13, and 16.